Everybody, so take some notes, get your notebooks and all that stuff. Follow along, feel free to ask questions, answer questions, and engage. Okay, you can ask me at any time if you have any questions. Fractions. Start with a letter definition first. So generally, or the word fraction. So what do we mean by a fraction? Besides, forget about math for a moment. What's the meaning of the word fraction in English?
A part of something else.
A part of something else, that's right. Or a portion or a piece, that's right. A portion of something. If you have, for example, a pizza and I said, give me a fraction of it, that means give me a piece of it. Math will define exactly how big or how small that piece is. That's why we need fractions. So we say a portion or a piece of something. Fraction, basically a portion of something. Okay, let's take again the example of a pizza. Let's say you have a pizza. I wanted exactly to get a piece of that. So I would say, for example, I want exactly this much. What is the fraction of this? How much, or the shaded part? What is exactly?
1/4.
1/4.
No, 1/4.
1/4. Very good. So we have a whole, one piece of something. We divide it into 4 equal pieces. Then we take 1 out of it. So we say 1/4 or 1 out of 4 or 1/4. And so 1/4 basically we can say is shaded or is taken or is cut from a whole or whatever. If 1/4 is shaded, what is the fraction of the non-shaded part?
3/4.
3/4, that's right. 3 out of a total of 4 pieces is not shaded. These pieces, so we say 3 out of 4 not shaded. Okay, so that's basically what the whole thing is about fractions. It's very specific. In math, we have to define it with certain numbers, quantities, amount. Not just use the term loosely like you would use in give me a piece of something or a fraction of that, a fraction of the price. You hear this a lot, quite often, a fraction of the price. It means a piece of the price or a portion, but how much exactly? So you need to do the math, percentages, whatever, to find that piece or that portion. Let me give you another example. Say that we have a whole piece of whatever this is, cake, a loaf of bread, meatloaf, whatever it is. Let's say you want to give someone exactly this fraction out of it. You want to give someone exactly this much from this. How would you go about doing that?
Divide 5 pieces.
Exactly. You're going to divide that into the denominator, this number here, into 5 equal pieces. So take that, divide into 5 equal 1, 2, 3, 4, 5. Here we divide it into 4 equal pieces. Here we divide into 5. And then how many of those pieces do we take?
2.
Based on this? Exactly. 2 out of 5. 2/5 or 2 out of 5, whatever you want to call it. 2/5 is shaded. Or, yep, that's right. The fraction, 2 out of 5 is shaded. And of course, the non-shaded part is represents how much? How much is not shaded as a fraction?
3/5.
Exactly. So 3/5 not shaded. And when you add the two, they add up to a whole. So when you add the two fractions together, they make up a whole out of this. So 2/5 plus 3/5. So basically just add the 2 to 3. That's 5 out of 5. So 5 out of 5 is 1 or a whole. Okay, we'll talk about adding and subtracting fractions in detail in the next in the future, in the next class. So that's basically the main idea of fractions. We just divide something into smaller pieces and we take a certain number of those pieces. That's all there is to it. And common fractions are half, for example, half divided into half, quarter, a third, 3/4. These are the common used fractions. So a fraction is made of two numbers. There's always a number over another number. And each one of these numbers has a specific name. We are more familiar with the bottom one. What do we call it?
Denominator.
Denominator.
Exactly, the denominator. What about the top? What do we call it?
Numerator.
Exactly, numerator. So each fraction has those two. A fraction is technically a division. So if you see it from this point of view, it means something out of something, however many out of however many pieces. Or in other words, it's basically a division. When you say A out of B, it's the same as saying A over B. Or you can also say A by V, A by B, A by B. That's another way of writing a fraction. Sometimes you write it like this. So we'll get back to these in a little moment. We're going to talk in details about types of fractions. Before that, let's talk a little bit about something called factoring. Before we come back to fractions and simplifying them, we need to learn something called factoring. Factoring is very simple. All it means is you take a number and you break it down into two or more numbers. 15 is basically 5 times 3. Okay, so 15 is 5 times 3. If the number, for example, if you have 18, we can also break it down into multiple numbers. Give me two numbers that multiply to 18. I need two numbers. I need two numbers that multiply to 18.
9 and 2.
9 and 2. 9 and 2. Someone has background noise. Please mute your mic. We hear some echo. Okay, so 18 is 9 and 2. We can even break down the 9 here into 3 and 3. The 2 we can't break down anymore, the 2 here. So this is as far as we can go. We can't break this down anymore. So basically 18, if we break it down, if we factor it, in other words, it's just 3 times 3 times 2. If you
Professor,
multiply,
I can't see your screen.
can you see the screen?
Sorry. Yeah, you have it turned right to you.
I'm sorry, you see it now?
Yeah.
Everybody, do you see my
Yes.
screen?
Yes.
Okay. All right. So basically 18, when we break it down, it's just 3 times 3 times 2. If you multiply these back, you look at 18. That's all we mean by factoring. You take a number and you break it down. That's all. And we call these numbers factors. We call them factors of 18 because those numbers, when multiplied, they make up basically 18. Depends how big the number is. Might be broken down into two numbers, maybe 3, maybe 5, 10. It all depends on how large the number is. So the bigger the number, the more factors you will have. Let's maybe try another number, a bigger one. If you take, for example, let's try maybe a bigger number, maybe 48 or 56. So it's better to use this tree. It looks like a tree form. We keep going basically vertically instead of going horizontally this way. So start with any two numbers. So 5 or 56. We can break it down into 8.
8 and 7.
Not 7, but 6, right? Is it?
Yes, 6.
Okay. And then we can we break this down even more to get something else?
Yes,
Yeah.
I have 8 by 2 and 6.
8.
Actually, 56 is 8 times. Someone, you were right. Whoever said 56.
7, right?
Seven.
Seven.
Yeah, you were right, actually. 7. not
7.
6.
Yeah.
That's right. So now, can we break the 7 down more? We can't, right? We can't break down the 7
No.
into numbers. It stays the same.
No.
But we can break down the 8.
8.
Yes.
First into maybe 4 and 2.
4.
Okay, and then continue, because we can continue the 4. We can turn it into 2 and 2,
2.
2, and
2.
7.
7.
And we can't go any further. As you can see, 2, 2, 2, and 7, that's all. Again, these are what we call the factors, or even better, we call them the prime factors. Have you guys heard of prime numbers before?
Yeah.
Prime factors. Can someone give us a definition of prime numbers?
It's numbers that can only be divided by itself and one.
That's the exact definition. Very good. That's the exact mathematical definition. The numbers can, in other words, in a simplified form, the numbers that cannot be broken down. Or in math, we say can only be divided by themselves and 1. You can't make 2 numbers out of it like we do with 15, 18, and so on. So prime factors. So those are prime factors of 56. So speaking of prime factors, so some numbers can be broken down. For example, 15. Other numbers cannot be broken down, are called a prime. So prime numbers cannot be broken down. What do we call the numbers that can be broken down? What do we call them? It's basically the opposite of prime.
I don't know in English, but in Spanish it's compuestos.
That's close enough. That's right. Composite. Okay, so we call them composite.
Composite.
That's right. So composite numbers, we can break them down, for example, 4, 8, 9, 10. All these we can break down into 2 and 2, 4 and 2, 3 and 3, 5 and 2. The numbers that we can't break down, or as you said, or someone said, can only be divided by themselves and 1 are called prime. They start from 2. So 2, then 3 is prime, 4 is not prime, is here, 5. What about 6? Is it composite or prime?
Composite.
Composite.
That's right. So 6 basically goes here. 7
7 prime.
is here. That's right. 8 is composite.
No, it's composite.
That's right.
So
9 also is
9.
composite. 10 is composite. What about 11? Is it composite or prime? 11.
Composite.
Prime.
Prime. We can't break down the 11, so it's prime. And so on. So prime numbers start from 2 and they go up. And we have many of them. And composite numbers, basically the opposite. Well, let's take a bigger number now, maybe 2 and 45. It's a random number here. The larger the number again, the more, actually, instead of that, let's use something simpler. 210, for example. Let's break the number 210 down. Basically, let's factor it. So again, when you do this, this is called factoring. You can start with any 2 numbers, okay? Any 2 numbers, and then you break them more if you can. Give me any 2 numbers that multiply to 21. 210. 210, since we have 0 here, it means we can multiply to 10. If you want to break it down into a multiplication, would be 10 times something, right? 10 times what? The number times 10 is 210. That number is 21, right? When you multiply anything by 10,
21.
add 0 to it, you get that number. Let's say we can break this down. 21 we can turn into
3 and 7.
That's right, 3 and 7, and 10 into
5 and 2.
5 and 2. We can't do anything here, so all these basically are prime numbers. 3, 7, 5, 2, they're all here. They're prime numbers. So 210 is basically the same as 3 times 7 times 5 times 2. So these are the prime numbers. So the number, and this is the factors. And that's why we call it factoring. So factoring is basically just breaking down number into its prime factors. Okay, that's all basically there is to it, just breaking down numbers. Any questions so far, everybody?
Professor, are you trying to show us the problems? Because we can't see it.
I am showing the screen. Yeah, I'm sharing it. You guys see it, right?
I see it.
Yeah, I see your
Me
share
too.
screen.
Yeah.
Can
Whoever is
see
not
it.
seeing it, I think you have an issue with your device. Maybe log in, log off, and log back in, or change the view. Change the
Okay.
view of your whatever device you're using. I am sharing the screen and everybody sees it. I'm writing on it.
I have one question. Why won't we be able to use calculators? I read that in practice.
Yeah. Was that? What's the second part of the question? I'm sorry.
I was doing the practice and I saw in a part of it that it said that we wasn't allowed to use calculators. Why?
Right. So this class is basically remedial. So we will teach you all the rules, all the basics, the signs, everything. When you get to an advanced level, next class in college algebra, that's when you can use a calculator to save time. But first we need to learn it. So this class, we assume, if you're in this class, we assume you don't know basically all the rules, you don't know all the calculations. We're going to make sure you know how to do them before we allow you to use a calculator, okay?
I ask because I did the practice already and
Okay.
the beginning was easy enough to do without a calculator, but then by the end of the exercises, there were big numbers.
When they are big numbers, I mean, it may allow you to use it if they are big numbers, but usually I don't give big numbers in the quizzes and exams. It's always under 1,000, multiply, add, subtract, so it shouldn't be that bad. Okay, so factoring, that's basically factoring. Let's move on to another thing. Simplifying fractions. Or before that, let's do types of fractions. Types. Types of fraction is basically, like we said earlier, each fraction is made of two sides, A and B. And there are actually two types of fractions based on which number of these is larger. So if the number here, the top number is greater or higher than the other number, the fraction is has a name or a type. What type of fraction is it when the number at the top is larger than the number at the bottom of the fraction?
Improper fraction.
Exactly, improper fractions. That's when the top is larger, so improper. Example, 7/4, 8/3, and so on, 17/6. So all these are called improper because the top number is bigger than the bottom number. And vice versa, or the other way around. If this number is smaller than this, A is less than B, what kind of fraction is it?
Proper.
Proper.
Right, proper. And again, example, 1/2, 7/9, 12/43, and so on. And basically, we can turn improper fractions. We can turn improper fractions into another type of numbers. Another type. When you have a fraction like this, we can turn it into something else. What type of number can we turn that into? Or can we convert?
Mix.
To a mixed number.
That's right. Convert. That's right. Convert improper fractions into mixed numbers. Let's see how to do that. Let's take one of these, for example, 7 out of 4. It's very simple to convert a mixed number into, or an improper fraction to a mixed number. So again, it's improper because the top is bigger than the bottom. Now, what we say is, how many times does 7 go into 4? 7 goes into, 4 goes into 7. How
2.
many times?
1.
One
One.
time. So you write 1. So 7 divided by 4, or 4 into 7, that's 1 time. Then you start a letter fraction right in the middle of the number, not the base of it, the middle of it. You bring over the same denominator. The same denominator remains the same. We need another number here. Basically, that's the remainder of the division. What is the remainder of this division?
3.
3. That's right. 4 goes into 7 once, and we have 3 left. So we put 3 here. So this is basically what we call a mixed number. Why do we call it a mixed number? Because it's made of a whole number and a fraction. So a whole part and a fraction part. Whole, and this one is a fraction. So when you have an improper fraction, you actually turn it into a mixed number made of 2 things, whole number and a fraction. And if you want to see this with the division operation, so basically 7 divided by 4, or 4 into 7, 4 into 7. This is how we basically where these numbers come from. If you're wondering why do we have these numbers here, so you do the regular division, 4 into 7, that's once. 1 times 4, that's 4. And you subtract, you have 3. What do we call 3 here in this division? What does 3 represent?
The remainder.
That's right, 3 is a remainder of the division.
Doesn't is
Right? The remainder is 3. So when you divide, you have a remainder. That's the number that's here. That's why we have 3 here. So 4 divided into 7 is 1. That's why we have 1 here. This number doesn't change, stays the same, the denominator. And what goes here is the remainder of this division. So 4 goes into 7 once. And the remainder is 3. So that 3 is why we have 3 here. In case you were wondering, that's basically what it is. It's pretty simple to convert improper fraction into mixed numbers, especially if the numbers are small. We can do that without actually, you don't have to do this, by the way. You don't have to do this division, unless you have maybe sometimes, this is not even for this. If you have big numbers, then you may do the division, the actual division, to find the remainder. Let's do another one. Let's do the other one, 8 over 3. That's improper fraction. So what is the mixed number here? But first of all, how many times does 3 go into 8?
2.
That's right. So 3 goes into 8, or 8 divided by 3 is twice. Start a letter fraction, bring over the same denominator, that's 3. So 3 goes into 8 twice, which is 6. What is the remainder?
2.
1, 2.
2. The remainder from 8 is 2. Again, if you want to do the division like this, 3 into 8, that's twice. 2 times 3, that's 6. You subtract, you have 2 left. Again, this is a remainder. This 2 is the one that goes here. This 2 comes from here. 8 divided by 3 is 2. Okay, so it's pretty simple to convert mixed numbers or improper fractions into mixed numbers. Let's do the other one, 17 over 6. Okay, what is the mixed number of this fraction? Or what's the whole part at least?
6 goes into 17 twice. So it's going to be
Okay.
2.
6 into 17 twice. Okay. What's the remainder? If 6 goes into 17 twice, that's 12. If you subtract it from 17, that would be
4.
5/6.
5. Would be 5. That's right. And again, always bring the same number over. Same denominator, same denominator. 17/6 is basically the same as 2 and 5/6. So these might be improper, or maybe they don't make sense. They don't make a lot of sense. That's the reason why we turn them into mixed numbers, because they tend to make more sense. We tend to make more sense of them when we convert them into mixed numbers. For example, if you said, or if you ask someone to give you 17/6 of something, they might not understand, it may not make a lot of sense. But instead, if you said, give me 2 5/6 of something, $2 5/6 of a dollar or something, this makes more sense. At least you know the whole part. So 2 whole of something plus some change here. But the fraction itself might not make as much sense. Same thing if you want to, let's say, get some pizza or something, say, give me 8 out of 3 pizzas. No, so I don't think anybody would understand that if you asked them 8 out of 3 of something. But if you said, give me 2 2/3 of something, they know what to give you: 2 whole parts, 2 whole pieces, or whole pies, and 2/3 out of 1 pie. 2/3 out of 1 pie, meaning take another pie, divide it into 3, take 2 pieces. For example, here, so you're going to say 2 whole ones, and 2/3 out of another one, maybe something like this. 1, 2, approximately this. So this is 2 2/3, 2 whole things, and the last one is only 2/3 full. So it makes more sense again. We can make sense of it. We can picture it when we have mixed numbers instead of improper fractions. Okay, does that make sense, everybody?
Yes.
All right, everybody else, any questions, anything about
No.
any of this problems?
Everything's
need-
clear.
All right, so everybody, please feel free to ask at any time. If you have any questions, anything, don't hesitate. So we're gonna need this a lot in the future when we add, multiply, subtract fractions, and mixed numbers. We're gonna be doing this a lot. So now we saw how to convert improper fractions into mixed numbers. Let's see how to go backwards. Okay, how to go backwards basically from this to this. So convert back. Convert. Let me say this here. Convert. You converting basically mixed numbers into improper fractions. Let's take the same examples and see how to turn them back into this. So 1 3/4. We want to make turn it back into the improper fraction it was. So how do you do that? How do you get the 7 from these two, from these whole and fraction? How do you get the number 7? We know that the denominator stays the same. The denominator stays the same. We need to get 7.
4 times 1 plus 3.
Exactly. So 4 times 1, we times these two, and we add the remainder. 1 times 4, that's 4 plus 3 is 7. We go back exactly to the original number. That's how simple it is. One way we divide.
What did you just do? What?
1 times 4, okay, plus 3 is 7. And the denominator, the 4, stays the same. Let's do another one. Let's do, for example, this one also. Let's go back from here to that number. So 2 2/3. Again, the denominator stays the same throughout all of this. It never changes. So now we need to get the 8. How do you get the 8 here? This 8. How do you get it from
2
these
times 3 plus 2.
That's right. So these 2 times 3 plus the remainder. These 2 here times this 1, 2 times 3. That's right. So 2. Let me write it down actually. So 2 times 3.
So the whole number times the
Mhm.
denominator plus the numerator.
Correct. So this is 2 here. So 2 times 3 plus 2, this is 8 over 3. For this one again, it's 1 times 4 plus 3 over 4. Again, make sure you multiply this way and you add the remainder. These are 2 separate problems. Let's do the last one also. Let's go back from mixed to improper. So we have 2 and 5/6. We're going to turn this back into a fraction, improper fraction. Again, the denominator remains the same. Then, how do you get this number here? The 17.
Is that a 5? 5
Right.
number on top?
Mm-hmm.
Oh,
5. 2 times.
17. 2
6
times
plus
6
5 plus 5.
5.
That's right. Plus the 5. That would be 17
17
over 6.
over 6.
So any number, basically, any mixed number can be turned easily to a fraction. Let's pick up another random one. Let's say 2 and 2 3/4, for example. That's a mixed number, the whole part, the fraction part. What is this equal to as a mixed number? As an improper fraction?
11.
11 over 4.
11 over 4, correct. Again, this is how you do it. 2 times 4, that's 8. Added to 3, that's 11. And the denominator always remains the same, whether you're doing this or this. That's basically how easy it is to convert back and forth between mixed numbers and improper fractions. And we need this a lot. Again, like I said, when we multiply, divide, and all of those operations with fractions, we use these conversions back and forth. And we'll see in a little bit. We'll see how to use that when we multiply, for example, or divide fractions. Okay, it's pretty simple, but it's very useful. Any questions, anyone?
No.
Okay, everybody else? All on board?
Yeah, we're good.
Okay.
I'm good too.
All right, let's see. Again, everybody, throughout the class, make sure you ask questions whenever you have questions, and also feel free to engage, answer questions. I like when everybody engages. You know, it's important, helps you learn, also it's good for your grade and all that stuff, as you know, participation is important. Converted. Next, let's see how to apply some of this when we multiply and divide fractions. Let's start with multiplication. So number 4. Multiplication of fractions. Generally speaking, when you have 2 fractions and you have something like this, how do you multiply 2 fractions in general? Or which way you multiply these 2 here?
On a straight lines. Numerator per denominator, denominator per denominator.
That's right, straight across. So 2 times 5 here, and 3 times 7. And of course, this is 10 out of 21. And that's basically it. That's how simple it is to Sorry, what's that? Someone say something? So 2 times 5, that's 10. 3 times 7, 21. And that's it. That's the answer here. Reduce it if possible. We're going to see how to reduce in a moment. So that's basically the answer here, 10 over 21. So let's talk a little bit about simplifying fractions. Before we do more of these, let's do simplifying fractions. Because that's important. We need that when we, before we do anything, we try to simplify fractions. So generally speaking, if you have a fraction with large numbers, we try to simplify it, we try to reduce it into the lowest terms. For example, if you have 15 and you have maybe 25 or 21, we try to simplify it or reduce it to lowest terms. Let's see what we mean by that. So basically to do that, we factor both. See how we did factor in here? We
Fine.
break down the numbers. We broke down 15, broke down 21, and so on. Same thing, that's what we do here. We basically break down both the numerator and the denominator. So that's 3 times 5. And how do you
7
factor
times
21?
7.
3
Yeah.
times
Sorry?
7 or 7 times 3?
That's right.
7 times 3.
So once you break them down, then you cancel any similar numbers, any common numbers. For example, 3 and 3 go away, and we have 5 over 7. So this is a better form of this fraction. It's simplified, or we can say it's reduced to the lowest terms. Lowest terms or the lowest numbers. So it is the same value, by the way. If you divide these two, it is the exact same thing as these two, but this one is much better. We'd rather have smaller fractions. That makes sense than having large fractions. So when you have smaller fractions, we can make sense of them easily. We can use them, we can shade them easily, we can add them, multiply them quicker than large numbers. So that's the reason why we simplify fractions, and always reduce your fractions to the lowest terms. The question will always say simplify, add, subtract, whatever, and reduce your answer to the lowest terms. That's what it means. I'll give you another example. So you have 18. So you have 27 over 18. That's also a fraction we try to simplify. Not every fraction can be simplified. Sometimes you may not have any common numbers to cancel. That's fine. But with experience, you can actually easily see whether there is a number in common or not between numbers. So let's break down both of these numbers. So 27 is basically what?
9 times 3.
9 times 3.
That's right. 27 is 9 times 3, which is 9
3
is
times 2.
3.
Or
3 times 3
3.
times 3, right? So 27. Let's write it down. Here we have 18. 18 we
6
can write as
times 3.
9.
6 times.
Okay,
Okay.
you can start
9
with that.
times.
That's fine. You can start with 3. 6 times 3, and then
2 times
3.
3
3.
that's
And
right,
1.
and 3.
and 3.
So 18 is basically 2 times 3 times 3. Okay, we factored both. We broke down both of these numbers. Now, what do we do next?
What's out?
Cross out the ones that are
Cancel.
similar. So the 3s.
That's right. So
4,
you
3.
cancel the common one, so we can cancel 3 and 3. We can cancel 3 and 3. And we end up with 3 over 2. So as you can see, these are the same, they're equal. Let's say you were trying to get, and of course you can now that we reduced it, it's an improper fraction. Let's make it a mixed number. What is 3 over 2 as a mixed number? 3 over 2 as a mixed
Repeat that
number is
question.
1 and 1/2.
1 and 1/2. 2 into 3 once, with the 2 here, and the remainder is 1. So you see how this is easier. This is easier to convert or to understand than this one.
What? How did you get 1 and then 1 over?
So 2 goes in. 2 goes into 3 once.
Oh.
Okay, and the
This
remainder is
is
1.
the lowest term. Okay.
Okay, the other one is the remainder from the division. So now, as you can see, it's easier to turn this one into a mixed number than this one. Or if you want to shade it, it's easier to shade this than to shade this. So always reduce your fractions to the lowest terms because that's useful. We give you another one, maybe this time with some bigger numbers. By the way, when you see something like this, some of you might be able to see the highest number that can go into both. Here's a second way, maybe a quicker way to do this. What's the highest number that can go into 27 and 18? What is the highest one, or that we can reduce? If you don't want to do
9.
it this way, 9. That's
9.
right. So you can either do it this way, you break everything down, but with experience, you can do it actually faster. You can actually notice that 9 goes into both. You can say this is 9 times 3. And 18 is 9 times 2.
Two.
You can just cancel that 9 quickly, and you get 3 over 2. Instead of breaking everything down, feel free to do these shortcuts if you can see what the highest number, if you can see the highest number that can go into both. You don't have to do it every time like this. This is just the basically the regular, the longer way, but you can definitely use a quicker way like this. 27 over 18 is the same, as you can see, get the same answer. Okay, any questions about simplifying, everybody? Simplifying is very important. It's really useful because we always try to simplify all the fractions, make them as simple as possible before we add or subtract or multiply them. Let's see, 27 or 18.
Can you do one more of those turning an improper fraction into a what was it you just did? From the mixed number to the, I think, to the improper fraction you just did?
Mixed number to the improper fraction?
Yeah. Can you do another problem like that?
Like these?
Yeah.
Okay, so for example, you have 3 and 1/2. So this is a mixed number. So to turn it into a fraction, first, keep the same denominator. Then you times these two this way, and you add this number to them. 3 times 2 is 6, plus 1, that's 7. Okay, 2 steps. Keep the same denominator, multiply and add these two.
And then you could break that down more, right? Because
if you want to go back to it, if you go back to this, basically you divide. You say 2 goes into 7 3 times. You write 3. Bring over the same denominator, and 2 goes into 7 3 times, which is 6. 1 is left. So you can go back and forth between these depending on what the question is. Okay.
Yeah, that's what I was asking. How do you go back and forth between two? Yeah. Thank you.
Okay. All right. So let's do one more. Maybe this time with maybe some bigger numbers. Let's say you have this and maybe 280. And again, we want to simplify or reduce this fraction to the lowest terms. What's the one thing we can do right away to simplify this fraction? Not completely, just the first quick step.
Eliminate the zeros.
Exactly, we can cancel the zeros right away. If you have 2 zeros and 2 zeros, we cancel them. 3 against 3, 1 against 1. Those can go away right away, and the fraction becomes much simpler. Now we can try to simplify again and use this. Just by looking at these two numbers, what do you think is the highest number that can go into both?
72.
7, right? Or you can break it both down, but you can see that 7 goes into both numbers. So the top one is 7 times 2.
2, and the bottom is 7 times 4.
Times, that's right, 7 times 4. You cancel
So
that out.
2 over 4.
That's right, we get 2 over 4. Can we reduce more? We have,
Yeah.
that's right, we can reduce
2
by,
and a half.
that's right, we can reduce by 2. We still have 2 in common here. So basically, this is a prime number. 2, we can't break it down. You can write it as 2 times 1. When you have a prime number that you can't break down, you can just write it as itself, times 1. But this one here is composite. We can write it as 2 times 2 and cancel those. So we have 1/2. Okay, so this whole fraction here, see how big that is? It's basically just means half. Maybe with experience, you can see it right away, right here. You may be able to tell that this is actually just 1/2 and you don't have to do any of this stuff. But this takes a lot of practice. Some of you might be able to do it right now, but it takes practice. At some point, you just look at the numbers and you see cancel the zeros, cancel the 7s, whatever, it would be half. And you do it right away in 2 seconds instead of doing all this math. But again, everything takes steps, takes practice. So if you add 2 fractions or multiply 2 fractions and you end up with an answer like this, it's much better when it's written like this. So always simplify or reduce your answer to the lowest terms. So this is what we call lowest terms. The number is still the same, the value is the same, but the format of the number is much simpler and different. Okay, so that's simplifying or reducing fractions. So back to multiplication, because this is very useful when it comes to multiplying. And so when you multiply 2 fractions, like we said earlier, you just multiply straight across. But it is actually very important to reduce first. Let's say you want to multiply this fraction by another fraction, this one here, 27 over 18. So as you can see here, although the rule is multiply straight across, doesn't mean you should do it. It's going to be a lot of work if you're going to multiply this. Again, we said we're not allowed to use calculators, so you'll have to do it on the side like this. It's going to take you time. Then you multiply the other 2. You're going to get some hundreds, the numbers in the hundreds. And then you end up with some fraction that's big like this, and you have to simplify it. That's a lot of work. That's why it's very important to actually reduce first. Let's see what happens if we use the reduced versions. Instead of using these large fractions, let's see what happens if we use the simplified versions of them. For example, 15 over 21, what is the simplest form of it? Or the simpler form? We reduced it into this, right? 15 over 21, we canceled, we had 5 over 7. What is the simpler form of 27 over 18?
1 over 2.
1/2.
3 over 2, sorry.
3 over 2.
Mm.
So basically, instead of multiplying these big ones, you see, it's much simpler to multiply the simplified version. It literally takes seconds instead of minutes of calculation. So we reduced all of this. So now we can just do 5 times 3, basic multiplication table, 7 times 2, that's 14. And you're done. Basically reduced. We use the reduced version instead of the actual numbers. Okay, so again, just because you can multiply straight across doesn't mean jump right ahead and do it right away. It's gonna take you a lot of time and increases your chances if you getting it wrong. So you wanna simplify it first, make the number smaller, so you don't have to basically spend a lot of time on it. And with the multiplication table, this can get even easier. So know your multiplication table at least between 0 to 10. Okay, print out a multiplication table. I'm sure it's online. You know, get a pictures, screenshot it, look at it on your phone. It will save you a lot of time. At least from 0 to 10. Because a lot of this stuff actually you use the subconsciously. You use the multiplication table in your head. You figure out, for example, these two have 9 in common, these two have 3 in common, by knowing the multiplication table. So you become faster and smarter, like just like a computer. You do it in your head without even realizing it. That's what I meant by unsubconsciously. Okay, everybody. So, any questions about this so far?
No.
Any questions about simplifying?
No.
All right, moving on.
So there is nothing we're gonna add or anything. It's always going to as we get the answer just by multiplying, and that's it. We end with multiply, right? That's it.
That's right. Multiply, try to reduce at the end. If you don't reduce here, you will have to reduce some big fractions like this at the end. This is an improper fraction. We can write it as a mixed number. What's the mixed number of this fraction, everybody? 15/14. We can write it as
1
Is 1 to
1/14, yes.
That's right. 14 goes into 15 once. Write the same denominator here. And the remainder from the division is 1. 14 goes into 15 once. If you subtract 14 from 15, you go. So this is useful, as you're going to see in the next, when we continue with the multiplication. So we did this one. This one didn't require any simplifying because the fractions were simple. Let's do a couple more examples. So this one here again was much easier to use the simplified versions. Let's make up another one. Let's say 35.
So, sir,
Yeah?
so the answer would be 15/14 only if it's saying, if the question saying just multiply in simplifying version, right? But if it's a mixed number, multiply and mixed number, then we go to at the end. Okay.
Correct, yeah. And also, if you start with mixed numbers here, you want your answer to be a mixed number, even if the question doesn't tell you so. If you started with mixed numbers,
right.
You're going to see that in a moment, okay?
We do all the steps and go to the mixed number, but if it doesn't ask for mixed number, just say simplify, that's all.
This would be fine, yeah. If it doesn't ask you to tell me, this would be fine.
Okay, thank you.
All right, so let's say another example. 35/45. We need some numbers here, say 8 and maybe 6, or maybe let's say 4. So look at this multiplication here. What do you think we can do, or can we simplify before multiplying these two fractions?
Yes.
We can. So first, start within each fraction. See if there is anything common. Just you may break them down. Actually, that's what we're going to do. We're going to break everything down. But first, start within each fraction. See if you can simplify. Nothing goes into these two. Nothing goes into these two. No common number. If that doesn't work, then you try this way. Do we have a common number? Can we?
5.
5. So we
Yes.
have 5 is common here, not because it appears here, but because if we break them down, each one of them has 5 times something. What about this? What's in common between these two?
2 or
2 or
2.
4.
Two.
That's right,
Four.
4 is better. Exactly, 4 is better. So let's break this down. So basically, we try to cancel the highest number possible, the highest common number possible. So for these two, we have 7 times 5. And 45 is, in terms of one of these,
9 times 5.
9 times 5.
5.
See that 5 now can cancel out. We're going to reduce it later. And for these two, we said 4 is the highest number that goes into both, so we can turn this into 4. And we don't need to break this one down because it has 4. We need that 4 against this one, so leave it alone like that. Maybe multiply it by itself so we don't change it. So the highest number common between these two is 4 and 4. The highest number between these two is 5 and 5. So we're going to cancel the 5 and the 5, cancel the 4 and the 4. So now we just have to multiply what's left, just small numbers here. So what's left at the top?
7.
7. Oh,
7 and
7 over 2.
Over 2.
7 times 1
Oh, 7 times 1.
and 2 times
2 times 9.
2 times 9.
2
times
times
9. Yeah.
7 over 18. And because we simplified here, you get the cleanest, nicest answer at the end. You don't have to simplify it. It's perfect. That's it. So that's the reason why, again, it's very important to simplify first. Imagine if you were multiplying this. This is 140. And then you have some large number, 300 something or 400 from here. And you'll have to spend time simplifying. So reduce before multiplying. It's very important to do so. Reduce.
That happened to me in the practice. I got a 2007 273 on 1.
That's why you were talking about the calculator?
Yes.
All right, now I see. Reduce before multiply. Okay, very important. So at the end, we save a lot of time. We save trouble when we reduce. So again, try to reduce each fraction on its own first. If not, reduce this way. When you cancel a number, it has to be one from the top against one from the bottom. They cannot be on the same side. It has to be one from any side here at the top against another one from the bottom. And cross those out. Most of the time, you'll end up with some small numbers like this. It takes you seconds to multiply like this. And you don't even have to reduce it. It's proper. No need to convert it or anything. So reduce before multiply. Any questions about these last two examples, everybody?
Professor,
Yeah?
that applies to all the numbers that are high, right?
That are high and that you can reduce. Not every time that it is possible to reduce. Sometimes you may not find anything common here, nothing common here, nothing common here or here. That's when you have to multiply anyway if you can't reduce. Most of the time you will have something to simplify. Okay, so let me give you another example here. Speaking of mixed numbers and the things that we just saw and improper fractions, let's say you have 5. You're going to multiply it by 2 or 1 and maybe 2/5. So see, this looks a lot unfamiliar because we were multiplying fractions, but now we have a mixed number, we have a whole number, they're completely different numbers. What do you think we need to do first?
Make it
you know,
into a
this-
fraction.
Turn everything into fractions.
Convert
That's
the
right.
fraction.
That's right. We know how to turn this into a fraction. We did it over and over again. How do we turn 5 into a fraction?
Put it
Put
over
it down
1.
1 as a
Put it over 1.
denominator.
That's right. Just put 1 in the denominator. You have a fraction. Let's convert this mixed number into a fraction. What do you get?
7/5.
7/5.
That's right. 1 times 5 plus 2, that's 7 over 5. So it's again on multiplication. What do we need? Can we simplify before multiplying? Always ask yourself this question.
The 5.
Simplify. We can cancel the 5s, right? Just like we canceled these 5s here and the 4s. Cancel that out. Or you may have to break down something. You may have to break down something. What's left now?
7.
That's right, 7 over
Over
1. So 7 is left here over 1, which is basically just 7.
7.
So the 1 here is irrelevant. You can add it if you want to turn it into a fraction. Once you're done with it, get rid of it. You get a whole number. So that's the reason why we learned the conversion earlier, so we can use it to multiply mixed numbers. So turn everything into fractions first, if they're not fractions. From there, just repeat the same process here of simplifying before multiplying. Even if it's two mixed numbers, you may have two mixed numbers, for example. So 2 and 1/5, for example, multiplied by maybe 1 3/10. 1 3/10, or rather, let's see. Please mute your mic. Whoever is talking and has noise, please mute your mic. Let's see another example here. Maybe so this time we have two mixed numbers, not just one, two of them. We want to multiply them. So what do we do first? What do we do first to multiply these two mixed numbers?
Turn them into fractions.
Turn them into
Fractions.
fractions, right? That's right. Mixed numbers, convert them to fractions. What's the
11
first?
over 5.
11 over
That's right. Multiply.
11
By
over
13
over
over
4.
Over 4.
That's right. 11 over 4. So that makes more sense now. It's much easier. Again, we know that we can multiply straight across, but before that, is there anything we can do, or can we simplify this before multiplying? Can we simplify anything here before multiplying?
I know that we can do something. I just don't know what it is.
Can we
all
cancel
right.
out 11?
multiply 11 by 11.
That's right. So we
can
can't
get-
cancel. We can't cancel the 11 and 11 because they're on the same side. They're both at the top. It has to be one here, both, and one at the bottom. It has to be one up, one down. They cannot cancel 11 and 11. So can't reduce this way, can't reduce this way, that way, that way. Nothing reduces. So you can go ahead and multiply. 11 times 11 is 1.
21.
121.
121, right? 5 times 4, that's 20.
No.
If we can't reduce here, don't worry, you can't reduce this. Don't even try to reduce it. If there was something to reduce, we would have seen it here. So try your best to reduce here. If you can't, that's not a problem. You can't reduce that. It's an improper fraction. We can write it as. It's an improper fraction, especially if you start with mixed numbers here. Make sure you write your final answer as a mixed number when possible. So this is improper. We can turn it into a mixed number. What's the mixed number of this? Or at least what's the whole part of it? What's the whole part and then the fraction part?
20.
So
21.
20 into 121. How many times does 20 go into 21? Think of it as money. How many 20s are in 120?
6.
6.
6, right? And what's the denominator here?
20.
20,
20 stays the same. How much is left?
1.
1. That's right. So if you have $120, that's 6 20s, and you have a single left. That's the remainder. And of course, the denominator stays the same.
What?
Money makes everything
Oh,
easier.
so 20 stays in the bottom. And
20, yeah, the denominator stays the same always. When you convert, it stays the same.
oh, the 6 times 20 goes with 121. That 6 comes in the front. Okay.
Right, so 20 goes into 121 6 times.
Oh.
Or feel free to do the regular division on the side. Most of the time you won't have to, but feel free to do it on the side. That's how you figure out this. So 20 goes into 121 6 times. 6 times 20 is 120. And you subtract, you get 1 left. So that 1 is what goes here. And the remainder stays, I mean, the denominator stays the same. So that's basically how you multiply mixed numbers.
This is how we did it in the beginning.
That's right. That's what we've been doing, yeah. We did it earlier here when we converted.
Convert mixed into improper. This is what it is?
Improper
Or
into mixed.
convert improper into mixed. Oh, okay.
That's right. Yeah, that's what we do. See the division, Okay. So now let's move on to the division. So that's how you multiply fractions and mixed numbers, whole numbers. Convert first if you have to, reduce, then multiply. You may have to reduce at the end or convert. Now let's do the division. The good news is division almost exactly like this. The division is just an extra step. Division is just an extra step, and then we repeat the same process of multiplying. So last section, last part 5. Division. When you divide two fractions, so 3/4, let's say 2/7, not 2/7, maybe 5/7. You have a division of two fractions. Any ideas on how to do this and how to divide two fractions? Everybody?
Yes.
Go ahead.
You keep the same and flip the second one.
You keep the first one and you flip the second one.
And flip the second
Okay,
one.
someone has an echo, please mute your mic. Someone has an echo, maybe you're connected from 2 devices or something. Please mute yourself. Yes, like you said, that's right. So whenever you have a division of fractions, first thing you want to do, forget about cross multiplying. First thing you want to do is keep, change, flip. So we're going to turn this into a multiplication. So we do what we call keep. That's right, keep, change, and flip. Keep, change, flip. What it means is keep that the same, the first one. You want to change your division into a multiplication. You flip this one, 7/5. That's what you do. Once you turn it into a multiplication, that's it. All of this again applies. Everything we learned so far also applies. All this stuff of multiplying, we repeat basically all of that again. So now again, now we have a multiplication. And again, before multiplying, see if you can reduce, cancel out anything. Can we reduce anything here or simplify?
No.
Nothing reduces, nothing simplifies. Okay, so what is this equal to?
21/20.
That's right, 21/20. As a mixed number, it would be
1/20.
1/20. Let's convert this into a mixed number. How would the mixed number be?
1.
28/20.
21 over 20. What is it as a mixed number? If you want to do the same thing.
1 and 1
One.
over 20 and 1 over 20.
That's right. 20 goes into 21 once. The remainder is 1. Okay, so again, with the division, you just one extra step, turn it into a multiplication and repeat all of this stuff all over again. And reduce, of course, don't forget to reduce before multiplying. Let me give you another one. Let's say you have 9 over 2. I'm going to divide this by.
Where did you end up with that 1 over 20? I'm sorry.
You want me to do division again?
No, I mean, yeah, that 20 goes one time with 21. I understand that.
Right.
That one goes in the front.
Yes. And what's left if 20 goes into 21 once? How much is left?
Right.
What's the remainder?
And 20 in the bottom. And what is the one?
The bottom, the 1.
Right.
Where
So 20.
on the, yes.
Let me ask you first. 20 goes into 21 once. How much is left from that? If 20 goes into 21 once, what's left over?
Yeah.
So the 1 that's left is what goes here.
So what is that one in the front? Which one is that in the front?
You do 20 times 1 and then you get 20 and then 21.
Let me do the division again for you, just like we did earlier here. So 20 into 21 goes once. 1 times 20. This 1 is what goes here, the first one.
In the front.
1 times 20.
Right.
1 times 20 is 20. You subtract, and we have 1 left. The remainder. This is another one. You made it to work on your division, okay? So work on your manual division to understand how division works. So this one is what we got, what comes here.
Oh, okay, thank you.
So 9 over 2 and maybe 15 over 4 here. So this time again, another division. What is the first thing you want to do when you have division?
So 9 over 2 times 4 over 15.
That's right. So we're going to do keep change flip first. Turn your division first into multiplication. So that's 9 over 2. Multiply 4 over 15. And again, once you're here, all that we learned previously here applies. So what happens next?
You could simplify it.
Exactly. So simplify or reduce. Maybe not in this fraction, not in this fraction, but we can reduce this way. We can reduce these by.
With 3.
Oh, 3,
by
yeah.
3. That's right. And this way by
2.
By 2. That's right. So basically 9 is 3. 3 times 3 times. This one is 3 times 5.
3 times 5.
This here is 2 times 1.
2 times 1 and 2 times 2.
Exactly. Now we can reduce, cancel any common numbers. Again, it has to be 1 from the top against 1 from the bottom. So cancel the 3, cancel the 2 against the 2. That's it. That's all that cancels. So now 3 times 2 over 1 times 5. Okay, 3 is left here. 2, 1 times 5, that's 6 over
6
5.
over 5.
All right, what is this as a mixed number?
1.
Oh, wow.
1 and 1/5.
That's right, 1 and 1/5. So reduce, simplify, and finally here, convert. So if you simplify here, you wouldn't have to simplify here. It's already simplified, as you can see, small numbers. Just need to convert it if it's an improper fraction. Okay, everybody, make sense?
Yes.
Yeah.
All right. Let's see.
Sir, can you show something that doesn't end up with 1 at the end?
Oh, sure.
You understand what I mean, right?
Right. We did a few of those earlier. So there is 1 here.
Yes, I think I remember we did something earlier.
Oh, this one is probably better. So 6 goes into 17.
That's
How many
right.
times?
Got it.
How many?
Got it.
How many?
Mhm.
6 into 17 twice.
6, yeah, twice, and
Bring
then
over the same number. Bring over the number here.
right.
How much is left when 6 goes into 17? What is left over or the remainder?
1.
No, no one. 6 goes into 17 twice, which is 12, right? If you
5
subtract
left.
that,
Yes, 5 left.
5. That's why we have 5.
Yes.
Okay,
got
it's
it.
not always 1. It's not always 1 here or here. So all depends on the numbers.
Yes, got it. Thank you.
Let's do another one. This time maybe with some mixed numbers. So let's say 2 and 1/5. Let's divide this by maybe 1 3/10. This is probably the longest one. So it involves mixed numbers and involves division. That means it's going to take a few steps. What is the very first step again we need to do here?
Convert it to improper fraction.
That's right. So we don't have fractions. We need to convert this first. Convert into fractions. And again, what is the mixed number?
11
The
over
improper-
5.
11 over 5. Okay. Divide.
Then
Divide.
13 over 10.
13 over 10.
13 over 10. Very good. What's the next step?
Keep change flip.
That's right. So now we have a fractions. We can repeat the same steps. Keep change flip. This will be
11 over 5 times 10 over 13.
10 over 13. Very good. What's next?
Simplify.
Simplify.
So break down the fractions or the numbers.
That's right. So nothing to cancel here, nothing this way, but this we can reduce by
2,
5.
5.
by 5.
5.
So this is how you do it faster on the fractions. You can say 5 goes into 5. How many times?
2.
One time.
1 time.
5 into 5 once, and 5 goes into 10
Twice.
2 twice.
twice. You can do it on the fraction, or you can also break it down here first. So, but you may do it this way as well. Now what we have left to multiply? 11 times.
11 times 2.
2
Okay.
1 times
and 1 times 13.
1 times 13. This is of course 22.
22 and
13.
13.
Okay, the last step.
Make it a
convert.
mixed number.
Okay, that mixed number would be
1.
Did you lose the screen like I did?
Yes.
Something weird is happening here. It went dark. Let me stop and restart. All right, so what is the next
1.
number again? 1.
1 and 9 over 13.
1 and 9 over 13. Very good. Okay, 1 and 9 over 13, and that's your final answer. So this is probably the longest one, so remember the steps. If you don't have fractions, get fractions first. Once you have fractions, if it's a division, turn it into a multiplication. Once you have a multiplication, before multiplying straight across, simplify that first. That way you don't have to do a lot of math. After simplifying it, you may have to convert it back if it's improper. Or if you didn't reduce in the beginning, you will have a hard time here. You will have a large fraction, you will have to simplify it. So simplify here if you didn't do it here.